For this series, we look at it and to decide convergence or divergence. The first thing you notice is a -1 to the n. Since n obviously changes from odd to even, this is an alternating series. To decide the convergence or divergence of an alternating series, you would take the limit as n approaches infinity of the non-alternating part. So you ignore the -1 to the n and take the limit of n over the natural log of 2n. Now, you can use dominant terms or L'Hopital's. N is dominant over the natural log. If you do it graphically, like a y equals x is linear, natural log looks like this. Even if it's double, out towards infinity, this graph is much greater in size and magnitude than this graph. So this is actually going to head towards infinity. So infinity is definitely not equal to 0, so we would say that this diverges by the nth term test. There's no need to do anything else. Now, if you don't know dominant terms and can't do that, you can use L'Hopital's rule. The derivative of n with respect to n is 1. The derivative of the natural log of 2n, well, the derivative of the natural log of u is u prime over u. It's 2 over 2n. And you're taking the limit as n approaches infinity of this. Well, when I divide by this fraction, I can multiply by the reciprocal. This is the limit as n approaches infinity of a 2n over 2. The 2's cancel out. Evaluate as n approaches infinity, and I get infinity. So either dominant terms or L'Hopital's. So this next series is suspicious because I don't actually see anything right away that would make it alternate, and you might not be sure what to do. You have a combination of cosine and an n, a polynomial. So you can't just plug in terms. The n pi should make you wonder a little bit. So if I look at this, my very first term would be a cosine where n equals 1, so cosine of pi over 1. My next term would be a cosine of 2 pi over 2. My next term would be a cosine of 3 pi over 3, plus it goes on forever. Well, I know cosine of pi from my unit circle is -1, so this is a -1. Cosine of 2 pi is a +1, so plus 1/2. Cosine of 3 pi is, we're back to -1, so minus 1/3. So the cosine of n pi is making the series alternate. It's actually like a -1 to a power. So I can say that this is an alternating series. Since it's alternating, I'll check the limit as n approaches infinity of the non-alternating part. So it's a 1 over n. I'm just looking at this cosine will be multiplied by 1, and I have an n in the denominator. 1 divided by infinity, this actually heads towards 0. And you can look, this is a decreasing sequence, 1 over n, because if I plug in a bigger n, it'll be smaller than the term before. 1 over n plus 1 is greater than 1 over n. So this series of cosine of n pi over n, I would say converges by the alternating series test.